Have you ever imagined a rock that could breathe? It sounds like something straight out of a science fiction movie, right? But what if I told you that scientists have recently discovered something almost exactly like that? It is a special kind of material called a breathing crystal. This incredible discovery, announced just a few months ago in August 2025, is causing a huge amount of excitement around the world. Scientists believe this new material could hold the key to solving some of our biggest challenges, especially when it comes to clean energy. It's a breakthrough so significant that some are even describing the crystal as being alive because of the fascinating way it interacts with its environment. This isn't just a tiny incremental step forward in science. This feels like a giant leap. Imagine a material that can physically swell up to inhale a gas, like taking a deep breath, and then shrink back down to exhale it. This is exactly what these new crystals do. They change their shape and size in response to the gases around them, almost like a living lung. The implications of this are enormous. We could use these crystals to store clean fuels like hydrogen much more safely, or to literally pull harmful carbon dioxide right out of the air. It's a game-changing technology that could reshape our world for the better. The team of researchers behind this discovery, from Busan National University in Korea and Hokkaido University in Japan, published their findings in the prestigious journal Nature Communications. This is a big deal in the science world, as it means their work has been carefully checked and verified by other experts. The specific crystal they developed is made from a combination of metals including strontium, iron, and cobalt. Its official name is a mouthful: SRFE 0.5, Co 0.5, O 2.5. But what it does is beautifully simple. It inhales and exhales gases, and it can do this over and over again without getting tired or breaking down. As we stand here on October 28, 2025, the world is buzzing with the potential of these breathing crystals. It's a story that brings together chemistry, engineering, and environmental science in a truly inspiring way. But what does it really mean for a crystal to be alive? And how can a non-living material help us build a cleaner, greener future for our planet? In the following sections, we will dive deep into the incredible science behind this discovery, explore its world-changing applications, and understand why countries are already competing to lead this new technological revolution. Let's explore this amazing new frontier together. So, what exactly is this breathing crystal? At its core, it is a type of material known as a metal organic framework, or MOF. You can think of a MOF like a microscopic sponge, but one that is incredibly well organized. It's built from metal ions, which act like the joints, and organic molecules, which act as the connecting rods. Together, they form a three-dimensional structure with countless tiny pores or pockets inside. These pores are what give the crystal its amazing ability to trap and store gas molecules. But what makes this particular crystal so special is that its structure isn't rigid, it's flexible and dynamic. When certain gases, like hydrogen or carbon dioxide, are introduced, the crystal's internal framework responds in a remarkable way. The gas molecules enter the pores, and the crystal begins to expand, almost like a balloon being inflated. Its internal volume can increase by as much as 30 to 40%. This physical swelling is the breathing in part. The crystal is literally making more room for the gas it is absorbing. Then, when conditions change, for example, if the pressure is lowered or the temperature is adjusted, the crystal releases the gas and contracts back to its original size. This is the breathing out part. This ability to swell and shrink in a controlled, repeatable cycle is what has led scientists to describe it as lifelike. It demonstrates a feedback mechanism, where the material actively responds to its surroundings. If you have a lot of gas, it inhales deeply. If the gas is removed, it exhales completely. This is very different from a normal rigid sponge that just passively fills up. The breathing crystal is an active participant in the process. The scientists who developed it found that it could perform this breathing cycle more than 10,000 times without showing any signs of damage or fatigue, proving it is incredibly stable and durable. The specific crystal developed by the joint Korean and Japanese team uses a special trick with its cobalt atoms. When it absorbs oxygen, the cobalt ions inside the crystal's structure change in a way that allows the framework to expand smoothly. When the oxygen is released, the cobalt ions change back, and the structure flawlessly returns to its original, smaller state. This selective and reversible chemical reaction is the secret to its high performance and stability. It's a masterpiece of molecular engineering, creating a material that behaves in a way we've only ever seen in biological systems until now. When scientists use a word like alive to describe a crystal, it definitely grabs your attention. It's a powerful and exciting way to explain what's happening. The crystal exhibits behaviors that we normally associate with living things. It responds to its environment, it changes its shape, and it has a cyclical, repeating process that looks a lot like breathing. An animal breathes in oxygen to use for energy and breathes out carbon dioxide. In a similar-looking way, this crystal breathes in gases to store them and breathes out to release them. This lifelike analogy makes a complex chemical process much easier for everyone to understand. However, it's very important to be clear. This crystal is not actually alive. It doesn't meet the biological definition of life. For something to be considered a living organism, it needs to have certain characteristics. It must be made of cells. It needs to be able to grow and develop. It must have a metabolism to process energy. It must be able to reproduce, and it must respond to stimuli as part of its survival. The breathing crystal does not have cells, it cannot reproduce to make more of itself, and it doesn't have a metabolism. Its breathing-like action is a purely chemical and physical reaction. So, why use the word alive at all? It's a form of scientific shorthand, a metaphor to help us visualize the dynamic nature of the material. Think about a smart thermostat in your home. It senses the temperature and turns the heat on or off in response. We might say it knows when it's too cold, but we understand it doesn't actually have a brain or feelings. In the same way, the crystal breathes in response to gas pressure, but it's not a conscious action. It's a predictable and programmed physical transformation based on the laws of chemistry and physics, not biology. Understanding this distinction is key. The beauty of the breathing crystal is not that it's a new life form, but that it's a brilliantly designed material that mimics a biological function. Scientists have engineered it at the atomic level to perform a specific task with incredible efficiency. It's a testament to human ingenuity and our growing ability to create materials with properties that were once thought to be possible only in nature. The crystal isn't alive, but its creation represents a massive step forward in the field of materials science, bringing us closer to a future where our technology works in harmony with natural processes. Let's dig a little deeper into the mechanics of how this amazing crystal actually works. The process is all about a delicate balance of pressure, temperature, and atomic structure. Imagine the crystal in its resting or exhaled state. Its internal framework is compact and the pores inside are small. The atoms are arranged in a stable, low-energy configuration. Now let's say we want to use it to store a gas, like hydrogen. We would introduce hydrogen gas into the container holding the crystals. As the pressure of the hydrogen gas increases, the gas molecules begin to push their way into the crystal's tiny pores. This is where the magic happens. The presence of the gas molecules inside the pores triggers a change in the crystal's structure. The bonds between the metal ions and the organic linkers are flexible enough to start stretching and rotating. The entire framework begins to open up, expanding to create more space. This is the inhalation. The crystal continues to absorb gas and expand until it reaches its maximum capacity, at which point its pores are full. This process is incredibly efficient because the crystal is actively participating, changing its shape to accommodate as many gas molecules as possible. Now, how do we get the gas back out? This is the exhalation part, and it's just as elegant. To release the stored hydrogen, we can simply lower the pressure in the container. As the external pressure drops, the gas molecules inside the crystal's pores start to flow out. With the gas molecules gone, the internal pressure that was holding the structure open disappears. The flexible framework then naturally relaxes and contracts, squeezing back down to its original compact size. The crystal has now exhaled, and it is ready to begin the cycle all over again. This process can also be controlled by temperature. In some cases, a gentle increase in temperature can provide the energy needed for the gas molecules to escape the pores, triggering the exhalation. The key takeaway is that the process is fully reversible and highly controllable. We can precisely manage when the crystal absorbs gas and when it releases it, simply by adjusting the environmental conditions. This level of control is what makes the breathing crystal not just a scientific curiosity, but a powerful tool with immense practical applications for our energy future. One of the most exciting applications for these breathing crystals is in the storage of hydrogen. Hydrogen is considered a fantastic clean fuel because, well, when you burn it, the only byproduct is water. However, storing hydrogen has always been a major challenge. It's actually the lightest element in the universe, which means it takes up a lot of space. To store it efficiently, you either have to compress it to extremely high pressures, which, requires strong, heavy and expensive tanks, or cool it down to a liquid state at an incredibly cold -253 degrees Celsius. Both of these methods are energy intensive and come with safety concerns. This is where breathing crystals could completely change the game. Instead of relying on high pressure or extreme cold, we could store hydrogen at a molecular level inside the pores of these crystals. The crystals would breathe in the hydrogen gas at a much lower, safer pressure and trap it within their structure. A tank filled with these crystals could store significantly more hydrogen in the same amount of space compared to a tank with just compressed gas. This would make hydrogen fuel cell vehicles much more practical, allowing them to have a longer driving range without needing giant heavy tanks. The safety benefits are also huge. Because the hydrogen is chemically bound within the crystal's pores, it is much more stable. In the event of an accident or a leak, the gas would be released much more slowly and controllably, rather than bursting out all at once from a high-pressure tank. The crystal acts as a natural safety valve. Furthermore, the crystal's breathing nature is self-throttling. It can only absorb or release gas at a certain rate, preventing dangerous pressure buildups or sudden discharges. This inherent safety feature is a massive selling point for using these materials in everyday applications, from cars to homes. Beyond vehicles, breathing crystals could also help stabilize our power grids. Renewable energy sources like wind and solar are fantastic, but they have a problem. They are intermittent. The sun doesn't always shine, and the wind doesn't always blow. During times of high production, we could use the excess electricity to create hydrogen through electrolysis. Then, large warehouses filled with breathing crystals could absorb this hydrogen, storing the energy. When demand for electricity spikes, the crystals could exhale the hydrogen, which would then be used in a fuel cell to generate electricity. This would create a reliable, clean energy buffer for our entire grid. Besides storing clean fuel, breathing crystals have another superpower. They can capture harmful greenhouse gases like carbon dioxide, or CO2, directly from the air or from industrial sources. This process is known as carbon capture, and it is considered one of the most important tools we have in the fight against climate change. Power plants, cement factories, and steel mills release enormous amounts of CO2 into the atmosphere. Capturing this CO2 at the source and preventing it from entering the air is a critical goal for nations around the world. Current carbon capture technologies often involve using liquid chemicals to absorb the CO2. This process works, but it can be very expensive and energy intensive. It requires a lot of heat to release the CO2 from the liquid so it can be stored, which costs money and creates its own carbon footprint. Breathing crystals offer a much more efficient alternative. We could create filters made of these crystals and place them in the smokestacks of industrial plants. As the exhaust gases pass through, the crystals would selectively breathe in and trap the CO2 molecules, while letting other harmless gases like nitrogen pass through. The release process is where the real savings come in. Instead of using a lot of heat, we could trigger the crystals to exhale the captured CO2 with just a small change in pressure. This makes the entire cycle of capture and release much less energy intensive and therefore much cheaper. The captured CO2 could then be compressed and stored safely underground in geological formations, or potentially even used to create new products, like carbon-neutral fuels or building materials. It's a way to turn a harmful waste product into a valuable resource. Imagine a future where these crystals are integrated everywhere. They could be used in large-scale direct air capture facilities that act like giant vacuums, pulling CO2 out of the open atmosphere. They could even be incorporated into building materials or air conditioning systems, allowing our homes and offices to actively clean the air around us. By designing crystals that are specifically tuned to capture CO2, we can create a powerful and versatile tool to help rebalance our planet's carbon cycle. This technology could be a critical piece of the puzzle in achieving our global climate goals and creating a more sustainable world for future generations. Whenever a technology with this much potential emerges, it's not just scientists who get excited. Governments and major industries around the world immediately take notice. The discovery of the breathing crystal has kicked off a new global competition, a race for what many are calling clean energy supremacy. The nations that can master the production and application of these materials will not only gain a huge economic advantage, but will also become leaders in the transition to a green economy. The United States, China, and the nations of the European Union are already positioning themselves to be at the forefront of this revolution. The United States is leveraging its strengths in research, innovation, and venture capital. Government agencies like the Department of Energy are likely to pour grants into research labs and startups working on these dynamic frameworks. There is also talk of the United States implementing export controls on the most advanced versions of these materials to maintain a technological edge. The goal is to nurture a domestic industry that can design, patent, and produce these crystals, ensuring that American companies lead the way in applications like hydrogen storage for electric vehicles and grid stabilization. Meanwhile, China is moving incredibly fast to scale up production. With its massive manufacturing capabilities and strong government support for green technologies, China is already accelerating plans to build pilot plants for hydrogen storage and carbon capture using these new materials. China also has a significant advantage in the supply chain for many of the raw materials and chemical solvents needed to create the crystals. Their strategy is focused on quickly translating laboratory breakthroughs into large-scale industrial applications, aiming to become the world's leading supplier of breathing crystal technology. The European Union is approaching the race from a different angle, focusing on regulation and market creation. The EU is known for setting ambitious environmental standards, and it plans to integrate these advanced materials into its Green Deal industrial strategy. By creating clear rules and incentives for companies to adopt technologies like solid-state carbon capture, the EU can build a massive, guaranteed market for breathing crystals. This will attract investment and drive innovation within its member states. This three-way competition between the United States, China, and the EU will accelerate the development and deployment of this technology on a global scale. In our fast-paced world, we are constantly bombarded with headlines about the next big thing. It can be hard to tell the difference between genuine scientific progress and overhyped claims. The story of the breathing crystal is a perfect example of what a real breakthrough looks like, and it teaches us what to watch for. The first and most important sign of a legitimate discovery is that it is published in a respected, peer-reviewed scientific journal. In this case, the research appeared in Nature Communications, which means that a panel of independent experts in the field reviewed the scientists' methods and results and agreed that they were sound. Another crucial step is replication. One lab's amazing result is exciting, but it only becomes established science when other independent labs can successfully repeat the experiment and get the same results. In the coming months and years, we should watch for announcements from other research groups around the world, confirming that they have been able to create their own breathing crystals with similar properties. This process of independent verification is the foundation of the scientific method and is what separates a one-time fluke from a reliable, game-changing technology. Always be skeptical of breakthroughs that no one else can seem to replicate. Beyond the lab, the real-world indicators of progress are just as important. Keep an eye out for a surge in patent filings related to terms like dynamic frameworks, metal-organic frameworks, or spin crossover materials. An increase in patents shows that companies and universities are actively investing time and money into developing commercial applications. Another huge sign to watch for is the announcement of pilot plants. When a company decides to build a small-scale factory to test the technology for hydrogen storage or a carbon capture hub, it means they are confident enough to move from theory to practice. Finally, look for partnerships and offtake agreements. When you see a major car company or a large utility provider signing a deal with a small startup that makes breathing crystals, it's a powerful vote of confidence. These agreements mean that the end users of the technology believe it is viable and are willing to commit resources to help bring it to market. By looking for these key signs, peer-reviewed publication, independent replication, patent activity, pilot plants, and industry partnerships, you can become a savvy observer of science and technology, able to spot the real breakthroughs that will truly shape our future. The discovery of the breathing crystal is more than just a fascinating piece of chemistry. It represents a fundamental shift in how we can think about and manage energy. For decades, our biggest obstacle in moving to a fully renewable energy system has been the problem of storage and transportation. We can generate clean electricity from the sun and wind, but it's difficult to store that energy for when it's dark or calm. We know hydrogen is a perfect clean fuel, but it's been too difficult and dangerous to handle safely. These new crystals offer an elegant and powerful solution to these long-standing problems. By providing a safe, dense, and efficient way to store hydrogen, breathing crystals could unlock the true potential of the hydrogen economy. We could see a future with long-range hydrogen-powered trucks, ships, and even airplanes, all running on clean fuel. Our power grids could become far more resilient, using vast reserves of hydrogen stored in these crystals to balance the intermittent nature of renewables and ensure a steady supply of electricity around the clock. This isn't just an improvement on existing technology. It is a whole new category of solution that could accelerate our transition away from fossil fuels. Similarly, the ability of these crystals to efficiently capture carbon dioxide offers us a vital tool in the fight against climate change. We can begin to clean up our most polluting industries, turning their emissions into a manageable solid instead of an atmospheric problem. This could buy us precious time as we work to decarbonize our entire economy. The breathing crystal is a prime example of how materials science can provide tangible solutions to our world's most pressing environmental challenges, offering hope and a practical path forward. It's a technology that works with chemistry and physics to help heal our planet. As we look ahead, the journey for breathing crystals is just beginning. It will take time to move from laboratory discoveries to mass market products. But the path is clear and the potential is undeniable. This is a foundational breakthrough, a platform technology that will likely lead to countless other innovations in areas like smart electronics, medicine, and beyond. The breathing crystal has shown us that by understanding the world at an atomic level, we can engineer materials that perform incredible, lifelike functions. It marks the dawn of a new era, one where we can build a cleaner, safer, and more sustainable energy future, one crystal at a time.